So now we are going to take up an example in which we have to find the extrema or maximum or minimum values of fx, y, z of functions subject to two constraints, right? Okay, so what that geometrically means is that, see, this and this gives two level surfaces. All right, so we have to find the max and min when x, y, and z, they are restricted on this curve of intersection of these two surfaces. And what happens there is this. Actually, I'm not going to go into the detail of that right now. So what you will have is that the gradient of f, which will of course be normal to the curve of intersection, that has to lie in the plane determined by the gradients of g and h at that point. And we are going to have the assumption that neither of these gradients is zero and these two are not parallel. So our strategy is this, that we shall first write gradient of f as linear combination of gradients of g and gradients of h, and then solve the resulting equations between among this and g equals constant and h equals constant, and compare the values. So let's take up our example. Now suppose that we have to find the extrema of this function subject to these two constraints, and we can rephrase this as this, that we want to find the extrema of this function subject to these two functions like g of x, y, z and h equal to zeros. So what we are going to do is that first we are going to form the equations and the coordinates of the points that satisfy these. All right, so let's see what kind of equations result from out of it. So first we have to write the gradient of this function. So we will write, so for gradient, the partial with respect to x here is what? Simply y. Okay, with respect to y will be what? Z here and x here. So we got z plus x, and then with respect to z, this part will give us a 0. Here we will simply get a y, all right? And then we have lambda times gradient of g. What is the gradient of g here? The gradient of g is going to be simply y, right? And then we have an x, and then we will have a 0, right? Plus what we get is mu times gradient of h, and that will be no x in here. So we will have a 0 here and 2y here, and then we have a 2z. So what do these give us? What do these equations give us? They give us that y equals lambda times y and then plus 0. So we will ignore that step. And then we get z plus x equals, like the middle one. So that will be lambda x, right, from here, plus 2 mu y to mu y from this part here, right? Okay. And then we get for the third one, do we have a y here, or I think I'm just checking it again. So that's y. Okay, so we have a y here again. That is all right. So we have a y equals, now here we will have a 0, and then we get what? Simply 2 mu z here, right? Okay, so very good. Now notice this, because we have this condition that product of x and y is 1, y cannot be 0, right? So since y cannot be 0, okay, what will this give us? This will give us lambda equals how much? 1. Why? Simply because y can't be 0, okay, as, all right, as xy equals 1. So I had said it, but still I'm writing it, just bear with it. Okay. All right, good. So we have lambda equals 1. And what does this give for mu? Because we have to eliminate both lambda and mu and use the other equations. And here it will mostly be by our own, like, it involves just, I would say, practice or observation or thinking, okay, that we have 2 mu equals y over z. So what we got is lambda is 1 and 2 mu is y over z. So what happens here is, and notice I think I have made a little mistake here. I should have had a lambda x. I don't know why I left it out here. Okay, I can play back and see if I said it or I didn't. But anyways, that implies that we have, what do we have? Z, this is a 1, right? And 2 mu is what? Y over z, right? So we will see what do we get from out of this, and then we are going to substitute those in the original equations, okay? So once we get this, you can see x and x, they will drop out. So let's just remove them and go slow now, because in this example, we are not spending as much time as we did in the example just before this. So what does this give us? This gives us that z square is going to be what? Y square, right? So when z square and y square are the same, then notice this, we have this equation, right? This condition rather, okay? So this condition gives me what? I can replace either of them by, by the other one. Let's replace z by y. So what this gives us is this, that 2y squared is 1. All right, so y will be plus or minus 1 over square root of 2, right? So let me write that down, 1 over square root of 2, and z is going to have the same values, right? So z is this, and then we can find the points x, and so we have found the points, and all we got to do is just compare the values of this at those points. So let's first finish finding the points. So xy is 1 means x is going to be, once we substitute this for y, what do we get? Plus or minus a square root of 2, right? So what do we get here as set of possible, or the points at which we have to come? So what we have now is we have a set of 8 points, a square root of 2, right? Then 1 over square root of 2, okay? And again 1 over square root of 2, and we can list them all, and I'm going to list them and bring them back to you. Here I listed all the points for you, and if we go ahead and find the values of f at these points. Okay, so z plus x, that's what we have, right? So 1 second. Let me first define this to be the function. Okay, now say I am computing or I am finding f at all these guys, right? Okay, then what that will be, y is the square root of 1 over square root of 2, and then z plus x would be how much? Z is again 1 over square root of 2 and x is the square root of 2. So if we multiply the square root of 2 in here, what shall we get? 1 over, this would be 1 over 2, that will be 1. So we are going to get how much? 3 over 2. So that is one possible value. And let's just go ahead and calculate the other ones. Now, before I go to the other ones, let's notice this, that I am careless in listing all these points because x, y is 1 means x and y are either positive together or negative together, right? So their signs cannot be opposite, as you can see here, under these assumptions. So here their signs were opposite, and where else do they have opposite signs? Right here, right? Okay. So again, so we have these many possibilities here, right? Okay. So now let's write the values. Sorry about that, and we caught it soon enough. Okay. So as I said, this is like we have to do it by inspection and we have to do it very carefully. Okay, so let's see what happens when both those guys are negative. Both those means I meant x and y are negative. Okay, so here's my equal sign. So that's 1/2. And then since the computer is computing that for me, I'm just going in an easy mode. Okay, so let's see what this is going to be. This is going to be 1/2 again. And let's see what that one is going to be for us. So we got this here. So, and that is 3 over 2. So what we got is that 3 over 2 is the maximum value and 1/2 is the minimum value. And these are the points at which they occur. All right.